So a rational function, we've seen some of these show up in some of the questions in the previous sections and finding inequalities, etc. But just to be clear, a rational function is a function of the form f of x equals some polynomial divided by some other polynomial. And we know what polynomials are, so we should be able to classify these. So we'll just go through some examples. So for a here, we've got a polynomial on the top, 3x squared plus 1. So that's good. And a polynomial on the bottom, 2x minus 5 is a linear polynomial, degree 1. And so we do have the right form. So f of x would in fact be a rational function. Now b, we've got f of x equals 5x cubed plus 2x. Now you notice it's not written as some p over q, but this one actually is rational because anything that is written kind of just standing there, we could just put over 1, and 1 is a degree 0 polynomial, right? Just like the integers are also rational numbers because we can write 7 over 1, 3 over 1, etc. So this one here in B is also rational. And C, you can see we've got the polynomial on the bottom, but on the top, because of the root, this is not a polynomial. So C is not going to be a rational function. Doesn't mean it's not a function, it just means it's going to behave differently, and we're not really going to investigate it in this section. And then finally, D is written a little bit differently. We're going to review some of those exponents soon. But if you remember anything to the -2 like that, what we can do is actually just rewrite that, and the minus will put the x squared on the bottom. So that's actually the same as 1 over x squared, and 1 and x squared are both polynomials, so this is in fact going to be rational as well. So just a few different ways that we can express rational functions. So yeah, there's not much to that. What we'll talk about now is going to be investigating some of the zeros. Okay, the zeros of any rational function, f of x equals p of x over q of x. So they're fairly easy to find. They're going to be the x's that are in the domain, and also so that p of x, just the top, is equal to 0. So we actually really are only interested in the top, and I'll explain why in the first example. So for this one, it's already nicely factored. We've got f of x is x minus 3 times x minus 2 over x plus 1, x minus 5. And so just to go through this one maybe in a little more detail than we would have to, if I was solving 0, let's say f of x equals 0, right? That's what it means to be a 0. Then I would have x minus 3, x minus 2 over x plus 1. Sorry, close that bracket. X minus 5 equals 0. And so what I would do is then multiply the denominator up to the other side, right? That's how we get rid of the fraction. So I would multiply this up by putting it over on the other side. And then what you see, it's 0 times a bunch of stuff. So it doesn't really matter what that denominator was because it ends up actually just being 0. So this is why we really only care about the numerator, this x minus 3, x minus 2 equals 0. And then that gives me my 2 zeros at x equals 3 and x equals 2. So I don't want to say we only care about the top, but it is the most important thing for us to look at here. We don't necessarily care what happens along the bottom. Okay, so for B, I'm going to just skip ahead here, and for my zeros, I'm just going to say it's where the top equals 0. So it would be where x squared plus 1 is 0. So if we want to look at this more carefully, what we have is x squared equals -1. Hopefully you'll see that that has absolutely no solutions because we can't have a square be negative. I should say there's no real solution. So that would have no zeros. And then finally, for C, I just want a little more space for this, so I'm going to move it up. So for C, if I do the same thing, I'm going to set the top to 0. And so that will be my x squared minus 4 equals 0. So x squared is 4. And then remember, when we undo that, that is that plus or minus 2 along the top. But this actually doesn't work. There is a little bit of a snag here. So I did say we only set the top to 0. And I said, be really careful about not caring about the bottom, because we do need to be mindful of this in the domain of f. Something can't be a 0 if you're not allowed to actually plug it into the function. So what you'll notice here is that I need to fix something, because I'm going to actually, I realized this should be a, let's see, for what I wanted to do for this example, I want that to be a minus. So I'm going to fix that and apologize instead of redoing this whole video. So I wanted this. And now hopefully maybe you can see what I'm talking about when I say that this doesn't work, because it did work a second ago. But with that minus 8 there, one of these answers doesn't work because one of these answers will give us a 0 on the bottom. So even though I kind of say like the bottom doesn't matter so much, it is still really important to have that factored so you can do any sort of simplifications. And for what we'll be doing in this section, you're going to want to factor everything anyway. So we are going to factor the bottom. If we were to factor the top, it would be that difference of squares. So it'd be x minus 2, x plus 2. And then the bottom, with that minus 8 there, that should be x minus 4 times x plus 2. Obviously didn't work with the plus 8. So what you'll actually see here is that there is some cancellation. You'd also recognize that plugging in minus 2 doesn't work, right? H of minus 2 is 0 over 0, which does not exist. So x equals negative 2 cannot be a 0, because it's undefined there. And the other way that we could see that is through actually just doing this cancellation of the x plus 2's. So in the simplified form, the only 0 from the top is x minus 2. So that's what you can do if you want to find the zeros, is simplify doing any cancellations that have to be done. And then find your zeros. So yeah, you should always simplify everything first and then get all of the conclusions. And that's actually going to work for some of the other stuff that we'll do throughout this section.